In meiosis, the process of synapsis requires the mother's DNA and the father's DNA to come together. Here, the chromosomes can go into recombination, or the act of crossing over. These create homologous pairs that can be shown here, while sometimes the DNA does not match up, as you can see by these colors in the reverse order here. The way the DNA can take care of this is by creating what is called an inversion loop in order to allow the DNA to match up correctly. Now, a way to show this is by going over how the mother's DNA and the father's DNA can include a crossing over event. So if we go down the mother's first strand of DNA, we can see it encodes for MIJKLHG, which is shown here. If we go down the mother's second strand of DNA, we can see it encodes for MIJ, but then crosses over here at this little detour at the centromere to KL and then back around to M, shown here. Now we can go on to the father's strand of DNA. Starting with M, we loop around to L, K, centromere J, I, H, and G. But if we go around to the father's second strand of DNA, starts off at G and H, loops around to I, J, but then crosses over at the centromere to K, L, and then back around to H and G. Now, these two strands of DNA have either too little or too much DNA, and then that creates a strand that will not encode for a viable offspring. It is unlikely that those individuals will survive to reproduce. Now, we can also show this via the process of a different order of DNA, showing MIJKLHG, and then the father being GHLKJIM. The order of the colors, aka the genes, are the same, so we can simply flip the father's DNA to encode that way. But if there is a crossing over event here, we can still see that it will encode for the same DNA, this strand, every time. So crossing over products, recombinant chromosomes are often not viable, while chromosomes that are matching are more likely to be viable.